Hello everyone. Today we're going to learn about acids. These are some types of strong acids. Hydrofluoric acid, nitric acid, sulfuric acid, hydrobromic acid, hydrohydric acid, perchloric acid, hydrofluoric acid. Now let's go to the next slide. Now let's talk about hydrochloric acid. It is a highly corrosive, strong mineral acid with many industrial uses. The molar mass being 36.46 g-mol, compound of a density of 1.18 grams centimeter cube. HCl can dissolve ionized only once to give up one H plus ion as single proton. And aqueous hydrochloric acid, the H plus joins the water molecule to form a hydronium ion, H30 plus. These are some hydrochloric acid pictures. Now let's talk about nitric acid. Nitric acid, HNO3, is colorless, fuming, and highly corrosive liquid at a freezing point of -42 Celsius, which is -44 Fahrenheit. Boiling point at 83 Celsius, which is 181 Fahrenheit. That is a common laboratory reagent and an important industrial chemical for the manufacture of fertilizers and explosives. It is toxic and can cause severe burns. Nitric acid is used in the production of ammonium nitrate for fertilizers, making plastics, and in the manufacture of dyes. It is also used for making explosives such as nitroglycerin and TNT. When it is combined with hydrochloric acid, an element called aqua regia is formed. Let's go to the next slide. Now, these are some nitric acid pictures. This is the formula for the nitric acid, which is HNO3. Now let's look at sulfuric acid in depth. H2S04, or more commonly known as sulfuric acid, is one of the most essential chemicals in the world. Around 231 million tons are produced internationally each year. It is a colorless hydrogen sulfide with no smell and exists in a syrupy liquid state that has a high boiling temperature. The major use of sulfuric acid is in the production of fertilizers, example superphosphate of lime and ammonium sulfate. It is widely used in the manufacture of chemicals, example in making hydrochloric acid, nitric acid, sulfate salt, synthetic detergents, dyes, and pigments, explosives, and drugs. Here, sulfuric acid is used to make hydrochloric acid and nitric acid. So, I think that hydrochloric acid is more powerful than sulfuric acid, and nitric acid is more powerful than sulfuric acid. Now, let's move to the next one. These are some sulfuric acid pictures. The formula of the sulfuric acid is H2SO4. Let's go to the next slide. Now let's see about hydrobromic acid. This is a colorless or very pale yellow liquid with a density of 1.49 g/ml and a boiling point of 122 to 124 Celsius and has a strong acid odor. Chemical properties. Hydrobromic acid is a very strong mineral acid and it is even stronger acid than hydrochloric acid. It reacts typically with bases to form bromide salts. The chief commercial source of bromine is ocean water, from which the element is extracted by means of chemical displacement, oxidation by chlorine, and the presence of sulfuric acid through the reaction. Now let's move to the next one. These are some hydrobromic acid pictures. Now let's talk about hydroiodic acid. Hydroiodic acid is not pure hydrogen iodide, but a mixture containing it. Commercial concentrated hydroiodic acid usually contains 48 to 57% Hi by mass. The solution forms the azeotrope boiling at 127 Celsius with 57% Hi, 43% of water. The high activity acidity is caused by the dispersal of ionic charge over the anion. Most used as a strong reduction agent because of its reducing ability and acidity. The primary application hydroiodic acid is used for the production of acetic acid. Although acetic acid is toxic to human in its concentrated form, is the basic chemical used to produce vinegar. Let's go to the next slide. These are some pictures of hydroiodic acids. Now let's look at perchloric acid. Perchloric acid is colorless, odorless, oily liquid that is extremely corrosive. Anhydrous perchloric acid and solutions greater than 85% W/W presents an explosion of shock. Spills of perchloric acid is a concentration less than 72% W/W may evaporate to higher, more hazardous concentrations. The corrosive chemical carries hazards typical of most acids. It is harmful if swallowed, causing digestive and respiratory tract burns. If exposed to the outside of your body, it can cause eye and skin burns. Additionally, perchloric acid is also explosively unstable under some conditions. Let's go to the next. These are some perchloric acid pictures. Now let's go to the next slide. Now, last but not least, hydrofluoric acid. It can exist a colorless gas or a fuming liquid, or it can be dissolved in water. When hydrogen fluoride is dissolved in water, it may be called hydrofluoric acid. Hydrogen fluoride can be released when other fluoride-containing compounds such as ammonium chloride and combine with water. When human tissue is exposed to the concentrated HF, the molecules dissociate into individual hydrogen and fluoride ions. The hydrogen ion burns like any other acid. Now let's move to the next one. These are some hydrofluoric acid pictures. Now let's move to the next slide. This is the end of my PowerPoint presentation, and I would like everyone to stay home and stay safe from the COVID-19 and go outside for emergency purposes. And please wear a mask when you go outside, and if possible, wear gloves and sanitizer. Thank you. I thank Google and Wikipedia for giving me information, and I thank all all of you for seeing my PowerPoint on assets. This is all for now.